The metal was cold enough to see your breath. December 15, 1967. 5:00 p.m. Exactly the moment when shift workers, Christmas shoppers, and families getting dinner groceries needed to cross the Ohio River between Point Pleasant, West Virginia and Canauga, Ohio. 37 vehicles were on the bridge when the sound started. Not a crack, not a snap, a groan. Steel doesn't groan unless it's dying. The fracture had been there since 1964. 3 years. Growing molecule by molecule through an Eyebar forged in 1927. A single piece of metal, 2 inches thick, holding up one end of a bridge that carried 4,000 vehicles daily. No backup, no redundancy, no safety factor. When that Eyebar finally gave up at 5:04 p.m., it took exactly 60 seconds for the entire 1,760-foot structure to collapse into the freezing Ohio River. 46 people died. Most were still in their cars when they hit the water. Christmas presents floated among the wreckage. But here's what makes this a different kind of disaster story. The crack was visible. Inspectors had seen corrosion on the eyebars. Local drivers had reported the bridge swaying in wind. Engineers had flagged the suspension system as obsolete. The state knew the bridge was past its design life. And they did nothing, because replacing one rural bridge seemed too expensive. Until it cost 46 lives and triggered a nationwide infrastructure crisis that revealed 8,000 American bridges were structurally deficient. This is the story of how 0.05 of an inch of metal defeated 40 years of engineering confidence. How expert warnings were dismissed until physics proved them catastrophically right. And how the deadliest bridge collapse in modern American history changed the way this country inspects every highway bridge. But first, we need to understand what made the Silver Bridge different from every other suspension bridge in America. And why that difference turned it into a ticking time bomb. The Silver Bridge was born from cost cutting. When the J.E. Grainer Company submitted their design proposal in 1927, they offered 2 options. Option 1, a traditional wire cable suspension bridge using proven technology. Safe, reliable, expensive. Option 2, an Eyebar chain suspension system using newly developed high-strength steel. Experimental, cheaper, untested in American bridge construction. The Gallia County, Ohio River Bridge Company chose option 2. They saved roughly $200,000. That decision would eventually kill 46 people. Meanwhile, at the American Bridge Company's manufacturing facility in Pittsburgh, workers were forging eyebars from a revolutionary new material. Heat-treated carbon steel with a maximum allowable stress of 50,000 pounds per square inch. More than twice the strength of standard mild steel. This allowed the bridge designers to use fewer eyebars per link, 2 bars instead of the standard 4 to 6 used in other suspension bridges. Benjamin Cedar, who would later survive the collapse, remembered the construction. Quote, "They told us it was the future of bridge building. Stronger steel meant fewer parts. Fewer parts meant faster construction. Everyone was excited about it. The Silver Bridge was going to be an engineering marvel." The design was indeed unique. Instead of thick cables woven from thousands of individual steel wires, the Silver Bridge hung from chains. Flat metal links shaped like elongated dog bones. Each eyebar was roughly 12 inches wide, 2 inches thick, and varied in length. The circular eyes at each end had holes through which steel pins connected one bar to the next. These eyebar chains descended from towers on both riverbanks, supporting the deck below through vertical suspension bars. The entire structure was 1,760 feet long. The center span, suspended over the Ohio River, measured 700 feet. 2 side spans of 380 feet each connected to the towers. The roadway sat 102 feet above the water. The towers themselves rested on rocker seats. Not bolted down, not anchored, just sitting there, held in place by the balanced tension of the suspension chains. This design allowed the towers to shift slightly as temperatures changed and loads varied. It also meant that if anything disrupted that balance, the towers would topple like dominoes. but we're getting ahead of ourselves. The Silver Bridge opened to traffic on Memorial Day, 1928. The aluminum paint gave it a distinctive silver sheen that caught sunlight and made it visible for miles. Locals immediately called it the Silver Bridge. The official name, Point Pleasant Bridge, never stuck. The bridge transformed the region. Before its construction, no direct route connected Columbus, Ohio to Charleston, West Virginia. Travelers faced long detours. Commercial traffic crawled. The Silver Bridge changed everything. It became known as the gateway to the South. Trucks, cars, families. Everyone used it. And the bridge handled the load. For years. Through the Depression. Through World War II. Through the post-war boom. It stood. It swayed sometimes, especially when heavy trucks crossed, but it stood. Jack Fowler, who would later become director of the Point Pleasant River Museum, remembered the motion. Quote, "The bridge was always swaying. It had this up and down motion from so much weight on it, and everybody always said, wow, this bridge is going to fall someday." People were unnerved by the motion, yet many accepted it as an aspect of the bridge's unique design. Meanwhile, something was happening inside Eyebar 330 that nobody could see. At Joint C13N, the first Eyebar connection west of the Ohio Tower on the north chain, a microscopic flaw existed in the steel. Probably from manufacturing, a tiny imperfection at a corrosion pit on the inner bearing surface where the Eyebar rotated against its connecting pin. In 1928, this flaw measured perhaps a few thousandths of an inch. Invisible, harmless, waiting. But Eyebar 330 experienced stress with every vehicle that crossed the bridge. The Eyebar rotated microscopically against the pin. Back and forth, up and down, thousands of times per day. 4,000 vehicles daily. Each crossing caused minute fretting wear. Metal grinding against metal, creating microscopic particles of steel that mixed with moisture. And here's where chemistry became catastrophic. Water and oxygen reached that tiny flaw. Iron oxide began forming, rust. But this wasn't surface rust that you could see and scrape away. This was internal corrosion, hidden inside the Eyebar joint where the steel wrapped around the pin. Protected from view by the very design that was supposed to make the bridge stronger. The crack grew, molecule by molecule, year by year, through a process called stress corrosion cracking. In 1955, state inspectors examined the Silver Bridge. Visual inspection only. They looked at the deck, the trussing, the exterior surfaces of the chain links. Everything appeared fine. The bridge was deemed safe. In 1961, another inspection. Same result. Safe. In 1965, yet another inspection. By this point, Eyebar 330 had a crack that measured approximately 0.1 inches deep. 1/10 of an inch. Thinner than a dime, hidden on the interior bearing surface where no visual inspection could detect it without disassembling the entire joint. The inspectors declared the bridge safe. But drivers knew something was wrong. The swaying had become more pronounced. The vibrations felt different. People started avoiding the bridge during heavy traffic. Steve Darst, whose father Alonzo Luther Darst would die in the collapse, later recalled his fear. Quote, "I hated crossing that bridge. It moved too much. You could feel it flexing under you. My friends and I used to joke about it collapsing. We'd hold our breath until we got across. It wasn't really a joke. We were scared." The mayor of Point Pleasant expressed concerns to state officials. He imposed temporary traffic limits during peak hours. State engineers assured him the bridge was structurally sound. The swaying was normal for suspension bridges. Nothing to worry about. Meanwhile, the crack in Eyebar 330 continued growing. By December 1967, it had reached critical size. The remaining intact steel could barely support the computed stress at that location. The Eyebar was operating at its absolute limit. It needed just one more thing. One final stress. One cold December evening when brittle fracture became inevitable. December 15, 1967 was a Friday. 10 days until Christmas. The weather was cold enough that snow flurries drifted through the gray afternoon sky. Temperatures hovered near freezing. The Ohio River flowed dark and fast, swollen from recent rains. Charlene Wood finished her shift at the beauty salon in Point Pleasant. She was pregnant, tired, ready to go home to Gallipolis, Ohio. She got into her brand new 1967 Pontiac, white with black vinyl top. She drove through Point Pleasant, stopped at the traffic light at 6th Street, waiting to turn onto the bridge approach. William Edmondson was behind the wheel of his Kenworth truck, hauling 35,000 pounds of tire fabric from Winston-Salem, North Carolina back to Detroit. He crossed the Silver Bridge 2 or 3 times every week. It was just another run, another paycheck. He was 38 years old. Marjorie Boggs, 18 years old, was driving with her husband Howard and their 17-month-old daughter. Christmas shopping done, heading home. The baby was in Marjorie's lap. No car seats in 1967. Just a mother's arms. Margaret May Cantrell drove with her husband Melvin in the passenger seat and their friend Cecil Clyde Counts in the back. They were heading downtown, running errands before dinner. Truck driver Bill Needham and his colleague Robert Toe were making the delivery run. The truck cab smelled like diesel and cigarettes. They'd cross the bridge, drop the load, head back. Simple. 37 vehicles total, 67 people, all of them approaching the Silver Bridge at exactly 5:00 p.m. on December 15, 1967. Rush hour, Christmas season, the worst possible timing. At 5:04 and approximately 30 seconds, Eyebar 330 failed. The crack had grown through combined stress corrosion and corrosion fatigue over 40 years of service. The cold temperature made the high-strength steel brittle. And at that moment, with traffic backed up from the traffic light in Point Pleasant, the bridge carried a full load. Not overloaded, well within its design capacity. But enough. The lower limb of the eye of Eyebar 330 fractured. Cleavage fracture. Brittle. No warning. The steel didn't bend. It snapped. Charlene Wood's light turned green. She started onto the bridge. She later told the Huntington Herald-Dispatch what happened next. Quote, "As I was approaching the bridge when the light changed. When it went to green, I started over the bridge and there was a terrible shaking of the bridge. My father was a riverboat captain and had talked about barges hitting the bridge and the pier. So when I heard that sound, I automatically put my car in reverse. She backed up, fast, her tires screaming on the roadway. The bridge surface ahead of her started dropping. Quote, by the time I got my car stopped, mine was on the very edge of where the bridge broke off. 4 feet, 20 centimeters. That's how close Charlene Wood came to dying. Her car sat on the edge of the break. In front of her, the bridge was gone. Just empty air where asphalt had been seconds before. When the lower side of Eyebar 330 failed, all the load transferred instantly to the upper side of the same Eyebar. That section hadn't been weakened by cracking, but it wasn't designed to carry double the load. It failed through ductile overload. The Eyebar ripped apart. Now joint C13N was held together by only 3 Eyebars instead of 4. The asymmetric load on the connecting pin caused it to twist. The remaining Eyebar on that side vibrated off the pin. Slipped off like a key off a keyring. The north chain was completely severed. What happened next took 60 seconds. But witnesses said it felt like both an eternity and an instant. The Ohio Tower, no longer held in balance by the north chain, began tilting north. Remember, the towers sat on rocker seats. Not bolted, not anchored, just balanced. The tower toppled, 700 tons of steel crashing over. As the tower fell, it pulled the suspension chains with it. The chains pulled the deck. The deck twisted, buckling upward in the center, folding like a piece of paper. The West Virginia Tower, pulled by the collapsing deck, and the falling Ohio Tower, toppled as well. Now both towers were going down. The entire center span lifted, twisted, and dropped into the Ohio River. Witnesses on both shores heard the sound. Multiple people described it as a shotgun blast. Others said it sounded like a freight train derailing. The metal screamed as it tore itself apart. William Edmondson felt his truck tilt right. He later recalled for the Daily Mail, quote, "The bridge shook unusually as I drove my rig over it. The bridge tilted right, collapsing and dumping me and everything on the deck into the Ohio River below. The impact launched Edmondson from the driver's seat through the passenger glass window. His truck hit the water and began sinking immediately. 35,000 pounds of cargo pulled it down. Edmondson thrashed in freezing water, disoriented, his arm broken, finding a wooden crate from his cargo. He clung to it, drifted downstream in the swift current. Marjorie Boggs' car plunged into the river with the collapsing bridge span. The vehicle hit the water and sank. Howard Boggs, her husband, somehow escaped through a window. He surfaced, gasping, the cold water shocking his system. He looked around frantically, screamed for Marjorie, screamed for his daughter. They were still in the car, sinking, the doors jammed from the impact, the windows intact, Marjorie and the baby trapped inside as the vehicle settled to the river bottom in 40 feet of water. Bill Needham's truck went in. He later recalled that he escaped through a broken window, found a box from his cargo, used it to float. 15 minutes in 38-degree water. Hypothermia setting in, shaking uncontrollably. His colleague Robert Toe never made it out of the truck. Meanwhile, Margaret May Cantrell experienced something extraordinary. As the bridge deck twisted and collapsed, a massive steel beam struck her car. But instead of crushing it or sending it into the river, the beam caught the vehicle and held it suspended on the uncollapsed portion of the bridge approach on the West Virginia side. Her husband Melvin, in the passenger seat, died on impact from the beam strike. Cecil Counts in the back seat, same. Margaret, behind the wheel, survived. Trapped in a car dangling over the void, surrounded by the dead, but alive. Rescue boats were on the water within minutes. The Point Pleasant Fire Department. Local businesses with river access. Private citizens who owned boats. They pulled people from the water. But the current was swift. The water was freezing, and many victims were already gone. State Trooper Rudy Odell was one of the first responders on the shore. He later said, quote, "I could hear them hollering for help. There was absolutely nothing I could do. It was a long way out into the water. The cold was the killer. Even people who survived the impact and escaped their vehicles faced hypothermia. The water temperature was 38 degrees Fahrenheit. You have maybe 10 to 15 minutes of useful muscle control in water that cold. After that, you can't swim. Can't hold on. Can't save yourself." By the time full darkness fell at 6 p.m., 46 people were dead or missing. 9 were injured. 31 of the 37 vehicles on the bridge had fallen. 24 vehicles went into the river. 7 fell on the Ohio shore. 6 vehicles remained on the intact approaches. 2 victims, Kathy Bias and Maxine Turner, were never found. Their bodies remain in the Ohio River to this day. The next morning, the scale of the disaster became clear. Twisted steel jutted from the water like broken bones. Vehicle roofs barely visible beneath the surface. The towers, those massive 700-ton structures, lay toppled on the riverbed and shore. The beautiful silver bridge that had stood for 39 years was gone. Obliterated in 60 seconds. The investigation began immediately. The National Transportation Safety Board had been created just 6 months earlier in April 1967. The Silver Bridge collapse became their first major highway accident investigation. NTSB investigators worked with experts from the Federal Highway Administration, the states of West Virginia and Ohio, and leading engineering consulting firms. They needed to understand what had happened. More importantly, they needed to understand why. Workers from the United States Army Corps of Engineers arrived with 5 barge-mounted cranes. Professional divers came with their equipment. But the conditions were brutal. The river current was swift. Recent rains had made the water murky. Visibility underwater was nearly zero. Max Ray, a deep-sea diver from New Orleans, surfaced from one dive and told reporters for the plain dealer, quote, "It's hairy and dangerous down there. You've got to worry about metal falling on you. I dropped through that mess, and it started to slide. It's so shaky, I could move those beams with my hand." For weeks, divers worked in the freezing water, attaching cables to wreckage. The cranes lifted twisted steel from the riverbed. Workers laid out the components in a large nearby field for analysis. It was like assembling a giant, deadly puzzle. And slowly, the puzzle revealed its secret. Eyebar 330. Joint C13N North Bar, North Chain, Ohio side span. The first Eyebar connection west of the Ohio Tower. That's where it started. The NTSB issued their interim report on October 4, 1968. Less than 10 months after the collapse. Quote, "It was determined that the fracture in suspension chain Eyebar 330 was essential to the catastrophic stage of the collapse. But they couldn't yet explain why that Eyebar had failed. That would take 3 more years of investigation." Meanwhile, the community tried to process the trauma. The Point Pleasant area had a population of roughly 6,000 people. In a town that small, everybody knew somebody who died. Families devastated, children orphaned, survivors racked with guilt. Ben Cedar, who crossed the bridge 5 minutes before it collapsed, later said, quote, "I was worried about that bridge every time I crossed over. If you got stuck in the middle of that bridge, it would wave back and forth, back and forth. But I never thought it would actually fall. You don't think these things will really happen. Until they do." 5 days after the collapse, President Lyndon Johnson appointed a task force to study bridge safety nationwide. The reality was sobering. In 1967, the United States had 1,800 bridges that were 40 years old or older. 1,100 of those were highway bridges designed for Model T traffic in the 1920s and 30s. Nobody had systematically checked if they could safely handle 1960s traffic loads. Only 17 states had adequate bridge inspection programs. 17 out of 50. The Highway Safety Act passed on August 24, 1968. Part of that act required the Department of Transportation to establish a formalized national program for bridge inspection and to train personnel to perform those inspections. But the NTSB still didn't have the complete answer. They knew Eyebar 330 had fractured. They knew that fracture caused the collapse. But what caused the fracture? And could it have been prevented? Laboratory analysis revealed the truth. The small crack, only about 0.1 inches deep, had initiated at a corrosion pit on the inner bearing surface of the Eyebar eye. That crack grew to critical size through the combined action of stress corrosion cracking and corrosion fatigue. The high-strength heat-treated steel, revolutionary in 1927, turned out to be vulnerable to this type of failure in ways that conventional mild steel wasn't. The material was strong but brittle, and the crack location, on the interior surface of the Eyebar hole, made it impossible to detect without completely disassembling the joint. The INSB's final report, issued December 16, 1970, concluded that the flaw, quote, "could not have been detected by any inspection method known in the state of the art today without disassembly of the joint." In other words, even if inspectors had known exactly what to look for and where to look, they couldn't have found it using 1960s inspection technology. The bridge was doomed from the moment that microscopic manufacturing flaw was forged into the steel in 1927. But here's the crucial point. The one that makes this disaster different from a mere accident. The bridge's design eliminated redundancy. Most Eyebar suspension bridges used 4 to 6 bars per link. Sometimes more. The Brooklyn Bridge used wire cables with thousands of individual strands. If one strand breaks, the others carry the load. The Silver Bridge used only 2 Eyebars per link. When one failed, the other couldn't carry double the load. Total failure was inevitable. Modern bridge designer David Steinman had built an Eyebar suspension bridge in Florianopolis, Brazil in 1926. Similar design to the Silver Bridge. But Steinman used 4 Eyebars per link instead of 2. and he thickened the Eyebar heads. That bridge operated until 1991 when it was closed for renovation due to corrosion. It reopened in 2019. Still standing today, the Silver Bridge designers had chosen cost savings over redundancy. 2 bars instead of 4. Thinner eyebars. Experimental high-strength steel. All to save money. The American Society of Civil Engineers reviewed historical Eyebar bridge designs. A quote from their 1903 panel of engineers evaluating chains for the Manhattan Bridge stated, "The chains have a decided advantage in the accessibility of all parts for inspection and protection, as well as in economy and rapidity of erection." But the Silver Bridge chains weren't accessible for inspection. The Eyebar joints were enclosed. The critical surfaces were hidden. The very places where cracks would form couldn't be seen. If you want to see what proper Eyebar design looks like, visit the Clifton Suspension Bridge in England. Designed by Isambard Kingdom Brunel. Built in 1864. Still in service today, the Eyebar chains are redundant in 2 dimensions. Multiple bars per link, accessible for inspection, over-engineered by modern standards. It's still standing because someone cared more about safety than saving money. The Silver Bridge was replaced by the Silver Memorial Bridge, completed in December 1969. Exactly 2 years after the original bridge fell. The new bridge is a cantilever design, not suspension. Cantilever bridges don't rely on chains or cables. The span is supported from below, not hung from above. Much safer for heavy traffic. The new bridge was built 1 mile downstream from the original Silver Bridge site. The old approach roads were abandoned. Point Pleasant had to be completely rerouted. The downtown area that once funneled directly onto the bridge was bypassed. But the real legacy of the Silver Bridge collapse wasn't a new bridge. It was the National Bridge Inspection Standards enacted in April 1971. Federal regulation requiring that all public bridges with spans over 20 feet must be inspected every 2 years. Bridges at higher risk require more frequent inspection. Bridges must be rated for load capacity. Weight limits must be posted and enforced. Within 15 months of the collapse, 10 more states had revised their bridge inspection standards. 24 states initiated entirely new programs. The entire country began looking at bridges differently, not as permanent monuments to engineering, but as aging structures that require constant vigilance. Tracy Brown, state bridge engineer for the West Virginia Division of Highways, said in a 2022 interview, quote, "The unexpected tragic collapse of the Silver Bridge on December 15, 1967, was an alarming wake-up call for bridge owners across the nation that our infrastructure was getting older and bridge conditions needed to be assessed on a routine schedule and in a systematic way. And here's the crucial question. Did it work? Have the National Bridge Inspection Standards prevented another Silver Bridge disaster? Mostly, but not entirely." In 1983, the Mianus River Bridge in Connecticut collapsed, killing 3 people. Inspection failures. In 2007, the I-35W Mississippi River Bridge in Minneapolis collapsed, killing 13 people. Design flaws that inspections missed. In 2009, an Eyebar failure was discovered in the San Francisco-Oakland Bay Bridge during a scheduled closure. Emergency repairs prevented a catastrophic collapse. But it was close, very close. The reality is that the United States has over 600,000 highway bridges. Many of them are decades past their design life. The American Society of Civil Engineers estimates that roughly 42,000 bridges are structurally deficient. Not necessarily unsafe, but requiring significant maintenance or replacement. The infrastructure crisis that the Silver Bridge collapse revealed hasn't gone away. It's gotten worse. We're just inspecting it now instead of ignoring it. But back to December 15, 1967. Back to the families. Back to the 46 lives that ended in freezing water because an invisible crack in metal decided to propagate at exactly 5:04 p.m. on a Friday evening. 18-year-old Marjorie Boggs and her 17-month-old daughter. Their bodies were found 6 weeks later in their crushed car at the bottom of the Ohio River. William Edmondson survived. pulled from the water by workers on a barge near where the Kanawha River meets the Ohio. Broken arm, multiple cuts, hypothermia, but alive. He attended a 50th anniversary memorial ceremony in 2017 at age 88. "The good Lord saved me," he said. Charlene Wood's quick thinking saved her life. She reversed her car just in time. She watched the bridge fold into the river from 4 feet away. She was pregnant. The trauma could have triggered a miscarriage. But her baby survived, born healthy months later, a life saved by her father's stories about barges hitting bridges. Margaret May Cantrell, trapped in her car on the uncollapsed approach with her dead husband and friend, was rescued from the wreckage. She survived, but she had to live with the memory of hearing other people drowning in the river below while she sat trapped among the dead. Paul Scott was in a car that sank to the bottom of the Ohio River. 2 of his companions died. He survived, and 15 days after the collapse, on December 30, 1967, he walked his daughter Carol down the aisle at her wedding. His arm still bandaged from his injuries. Kathy Bias and Maxine Turner were never found. Their families never got to bury them. Never got closure, just the knowledge that somewhere in the Ohio River, their loved ones rest. Every December 15th, Point Pleasant holds a memorial ceremony at the site where the bridge approached 6th Street. Families gather, survivors speak. They remember the 46 precious souls lost because 5/100ths of an inch of metal couldn't hold. Steve and Anita Chapman, Point Pleasant natives now living in Nashville, wrote a song about the bridge. They performed it at the 50th anniversary ceremony. The lyrics capture what the bridge meant to the community. Quote, "How many times did I cross that span that testified once to the genius of man? She was part of our families, a friend to us all. But we never thought she would fall. We never thought that at all." The Point Pleasant River Museum kept an Eyebar assembly from the original silver bridge on display. Cleaned and painted to look like new. A reminder of what failed. Pete Lewis, a museum curator, explained the assembly to visitors. Quote, "This is a typical Eyebar joint from the Silver Bridge, which was rescued after the disaster. It comprises a central pin over which the eyebars would have been pivoted, and the whole assembly is encapsulated by the very solid end caps, which themselves are attached by 1-inch bolts through the center of the pin. Simple, elegant, strong, until it wasn't." In 2019, the American Society of Civil Engineers dedicated a National Historic Civil Engineering Landmark plaque at the Silver Bridge site. The designation recognizes the bridge's significance not for its engineering achievement, but for what its failure taught the nation. The plaque doesn't mention the cost savings. Doesn't mention the decision to use 2 eyebars instead of 4. Doesn't mention the experimental steel or the inaccessible design. It just states the facts. Built in 1928. Collapsed December 15, 1967. Led to the National Bridge Inspection Standards. But if you want to understand what really happened, you need to look deeper. You need to see the pattern that repeats across industrial disasters. Expert warnings dismissed. Cost-cutting prioritized over safety. Invisible flaws allowed to grow unchecked. Then catastrophe. Then regulation. Then the slow forgetting until the next disaster. The Silver Bridge collapse follows the same pattern as every preventable tragedy in this series. Working-class people knew the bridge was dangerous. They felt it swaying. They reported it. The mayor expressed concerns. But state engineers assured everyone it was safe. Until it wasn't. Until 46 people died. Until Christmas presents floated among the wreckage. Until families drowned together in freezing water because an invisible crack reached critical size and an industry chose profit over redundancy. The bridge didn't fail on December 15, 1967. The bridge failed in 1927 when designers chose cost savings over safety. The collapse was 40 years of deferred consequences finally demanding payment. And 46 people paid the price. If you found this story valuable, please hit the like button. It helps more people understand how infrastructure failures happen and why vigilance matters. And if you want to dive deeper into disasters where expert warnings were ignored until catastrophe struck, make sure you're subscribed. Because every week, we're exposing how institutional negligence, cost-cutting, and ignored warnings lead to preventable tragedies. The Silver Bridge stood for 39 years and 29 days. It collapsed in 60 seconds. Those 60 seconds changed American infrastructure policy forever. Because sometimes it takes 46 deaths to teach a lesson that should have been obvious from the start. Don't build critical infrastructure without redundancy. Don't cut costs on safety systems. Don't ignore visible warning signs because inspections are inconvenient. And don't trust that something will keep working forever just because it's worked so far. 0.05 of an inch. That's all it took. 1/10 of an inch of crack in a single eyebar. Hidden, growing, waiting, until a cold December evening when 46 people needed to cross a river and a bridge decided it had carried its last load. Charlene Wood still lives in Gallipolis, Ohio. She's in her 80s now. And she still remembers December 15, 1967. The day she put her car in reverse and saved her life. William Edmondson is 93 years old. He survived the freezing water, the broken arm, the near drowning. He still remembers the bridge tilting, the impact, the desperate fight to reach the surface. And in Point Pleasant, every December 15th, they gather. They read the names. All 46. They remember what was lost. And they remind themselves why bridges must be inspected, maintained, and replaced before invisible cracks reach critical size. Because the Silver Bridge isn't history. It's a warning. The crack in Eyebar 330 is every ignored warning, every deferred maintenance, every cost-saving measure that trades safety for profit. It's every time someone says, "It's been working fine so far." Until it doesn't, until the metal groans, until the bridge folds like a deck of cards, until 46 people learn that "worked fine so far" isn't a safety standard. The National Bridge Inspection Standards inspect over 600,000 bridges every 2 years. They rate them, they measure them, they load test them, all because of December 15, 1967. All because 46 people died when one invisible crack decided it had grown far enough. That's the legacy of the Silver Bridge collapse. Not the bridge itself, not the engineering innovation, not the cost savings. The legacy is the recognition that infrastructure requires constant vigilance. That safety systems need redundancy. That expert warnings matter. That visible swaying means something's wrong. And that 0.05 of an inch of metal, growing molecule by molecule for 40 years in the darkness inside an eyebar joint, can kill 46 people in 60 seconds if we're not paying attention. The bridge is gone, but the lesson remains. Ignore it at your peril.